All right, let's talk about something that honestly affects every single one of us. We're going to explore why the very foundation of how our computers understand time is, well, broken, and what that really means for the safety of your data in the cloud.
Have you ever had that moment? You're working on a file in iCloud or Google Drive, you save it, and then it just changes? Or worse, an older version just magically reappears, wiping out hours of your work. It's maddening, right? And you probably think, ugh, what a stupid bug. But what if I told you it's not a bug at all? What if it's a symptom of a problem that goes all the way down to the fundamental laws of physics? And get this quote is from 1983. That's right. For over 40 years, computer scientists have known that keeping data perfectly in sync across different computers is a monumental challenge. So no, this isn't some new bug in the latest app update. It's a deep foundational crack in our entire digital world.
So let's use Apple's iCloud as our way into this whole mystery. For years, people have reported that iCloud can just silently delete or change their files. Now, this isn't about picking on Apple. It's just a perfect real-world example of this much deeper issue.
See, for years, we've been treating data corruption like it's just a simple sync error. You know, a glitch in the matrix. But the real problem is so much bigger than that. It turns out our computers are literally built on a flawed assumption about how time and reality actually work.
To try and fix this, the tech world basically went on this epic quest, the quest for one perfect, universal clock. The idea seems so simple, so elegant. If every single computer in the world agreed on the exact same time, down to the nanosecond, we could put every event in a perfect, unchangeable order. Problem solved.
And I'm not talking about some small time effort. The systems you see here, they represent billions of dollars poured into this idea by the biggest names in tech. Companies like Google built incredible systems like Spanner, using atomic clocks and GPS, all to try and force their thousands of servers onto a single, unified timeline.
The dream, right? The ultimate goal is to create this single global truth, a master timeline where event A is guaranteed to have happened before event B for every computer, everywhere, all the time. It sounds like the perfect solution, doesn't it? Well, there's just one tiny problem. It's built on a lie.
And that lie? Well, that brings us to the real villain of our story. And it's not a piece of code or a faulty server. It's a deeply flawed idea that we call the Minkowski fallacy.
This quote just nails it. We're building our most critical digital infrastructure as if time is this simple, absolute clock-on-the-wall thing that Isaac Newton described hundreds of years ago. But we've known for over a century, since Einstein, that reality is just so much weirder than that.
Okay, so what is the Minkowski fallacy? In simple terms, it's the belief that time is a perfect, smooth line, that it's always moving forward at the exact same speed for everyone, everywhere. It's how we feel time. It's intuitive, and it's totally, completely wrong.
This is the mental model that is baked into practically every line of code we write. We just assume this smooth, predictable timeline exists. But what happens when you actually start measuring time with insane levels of precision? Well, the illusion shatters.
Okay, now this is where it gets really interesting. Researchers took two incredibly precise clocks and measured the time between them. Now, our simple model of time, the expected result, says the data should be neat and clean. There should be a forbidden zone where no data points can possibly appear. But look at the actual result. They found data points inside that impossible zone. This is hard proof that time, at these scales, isn't a clean line. It's a messy, probabilistic cloud of uncertainty.
And physics actually has a name for this wild beast: indefinite causality. It's a proven concept from quantum mechanics where, at a certain level, the very order of cause and effect can get blurry. An event can be both before and after another event simultaneously. Think about that for a second. Our computer systems have absolutely no way of dealing with that reality. So what happens when you build these massive, global-scale systems on top of a model of time that is fundamentally wrong? You're not actually making things safer. You're just making the inevitable failure more precise and way more catastrophic.
This analogy is just wow. It's perfect. Spending more and more money on ever more precise clocks without admitting the underlying model is wrong is like meticulously sharpening the blade of a guillotine. You're not preventing the execution. You're just making sure that when the blade finally drops, the cut is devastatingly clean. And this isn't some obscure problem. Take TCP, the protocol that basically runs the internet. It's built from the ground up on the Minkowski fallacy. It assumes time only moves forward, and that a second for you is the same as a second for the server. But when the messy reality of space-time proves that assumption wrong, even for a microsecond, what do you get? Data corruption. The exact kind we see in our cloud files.
Okay, so if forcing everything onto one timeline is just a fool's errand, what's the answer? Well, we need a complete shift in how we think about this. We have to stop trying to command time and instead learn how to have a conversation with it.
Let's just lay it out side by side. The old way is all about fighting against the nature of space-time, trying to force this impossible global order. But the new way, it's about working with space-time. It accepts that there is no universal now, and instead it focuses on understanding the causal relationship between events from their own unique local points of view. This is really the key thing to wrap your head around. Time isn't some universal river we're all floating down together, it's a local experience. For any one computer, any observer, its local time moves forward when it gets new information. And if it loses information, like a dropped network packet, for that computer, its understanding of the system state has just effectively gone backward in time.
So, how do we actually build anything with this? If we accept that time is local and fragmented, how in the world do we build systems that are coherent and reliable? And that jigsaw puzzle, that is the perfect way to think about it. Reality doesn't hand us a fully assembled, beautiful picture of events. It gives us a box full of jagged, disconnected pieces. Each piece is just one computer's local, partial view of what happened. Our job as engineers isn't to pretend it's one smooth picture. It's to design systems smart enough to figure out how the pieces fit together.
And you know what? At its core, this isn't just a computer science problem. It's a communication problem. When your laptop sends a file to a server, it operates under the illusion that the communication was perfect. But reality is messy. The real challenge is to build systems that never, ever take successful communication for granted.
So ultimately, it all comes down to this big shift in thinking. We have to stop picturing our data as this calm, static lake where everything has a fixed, known position. We have to start seeing it as a constantly flowing river, a dynamic, ever-changing system of events and relationships that we can learn to navigate, but never truly control.
So I'm going to leave you with this thought. For half a century, we have tried to tame time, to wrestle it into a neat, predictable line. But what if that was the wrong goal all along? What new kinds of resilient, incredible systems could we build if we just stopped fighting reality and started to embrace the true, wild, and beautiful nature of space-time?